Hello, grade 7. In this lesson, I will answer questions 4 and 5 from worksheet 2 density and questions 1 and 2 from the end of unit questions page 138. And this will be our final lesson for this semester. After I finish and after you review your answers, please, if you have any questions, don't hesitate to ask me. I'll be ready to answer any questions. So let's start with question 4. A stone is made of material with density of 2.7 grams per centimeters cubic. Its mass is 94.5 grams. Calculate the volume of the stone. So let's start with what do we know and what do we need to know. We know the density of the stone is 2.7 grams per centimeters cubic. We know the mass, which is 94.5 grams. We need to know the volume. I prefer that you all use this method of working when you answer any calculations. Put what you already know with the units and what you need to know. This will make everything clearer for you, so you won't have any difficulty answer any question. So this is straightforward. We know density, mass, the units, grams per grams, and we need to calculate the volume. We need to rearrange the formula of density. So density equals mass over volume. I need to calculate the volume, so I cover the volume. Now, what I have remaining is mass divided by density. So volume equals mass divided by density. I replace my values, 94.5 grams per density, 2.7 grams per cubic centimeters, and the volume is 35 centimeters cubic. This is the volume of the stone. Question 5. This question might seem a little bit tricky at the beginning, and many of you sent me messages saying that they couldn't answer some parts of it. This is a very simple question, but you have to pay attention to the information that you're given. So let's start by reading the question. The density of water is 1 grams per centimeters cubic. This is useful as it means we can measure the mass of water and easily work out its volume. What does that mean? When I have a density of 1 grams per centimeters cubic, this means that if I have a volume of 1 centimeter cubic of water, so this cube is 1 centimeter by 1 centimeter by 1 centimeter. And if I put it on a scale or a balance, because density of water is 1 gram per centimeters cubic, this means that the reading of the scale or the mass of this 1 centimeter cubic of water will be 1 grams. This is useful because whatever volume do I have of water, I can work out its mass, and whatever mass I have of water, I can work out its volume. What do I mean by that? Let's say I put 20 cubic centimeters like this on the scale. If one has a mass of 1 gram, then 20 will have a mass of 20 grams. Or let's say I put an unknown volume of water on the scale and it gives me a reading of, let's say, 30 grams. I can immediately know that I have 30 cubic centimeters on the scale. So let's look at the questions. What is the mass of 1 centimeter cubic of water? As I said, from the definition of density, density is the mass of a known volume of a certain material. The known volume here is 1 centimeter cubic. So if the density is 1 gram per centimeter cubic, the mass of this centimeter cubic is 1 grams. So the mass of 1 centimeter cubic is 1 gram. What is the mass of 20 centimeters cubic of water? Again, if we multiply this by 20, the mass will be multiplied by 20. We don't need to do any calculations here, just think of it. So 20 grams. What is the volume of 10 grams of water? Now the scale reads 10 grams. I will immediately know that I have 10 centimeters cubic on the scale. What is the volume of 22.5 grams of water? Again, because the density is 1, so the volume will be the same as the mass, 22.5 centimeters cubic. Now, why did we use that? Or why do we need to understand that? Now, we use water to help us identify densities of different liquids. You will see through this question that liquids, they take the volume of their containers. So if we make use of the information of the density of water and our ability to calculate its volume and mass, we will be able to calculate the volume of any container if we have water and a balance. Let's see how. Milan is measuring the density of ethanol. So now the liquid that we are working on is ethanol. He weighs a bottle 3 times. First, empty. So the first time he weighs the bottle is when it was empty. He needs the volume of the empty container, because if you want to take the mass of the liquid, you need a container. And eventually you need to subtract the mass of the container. So again, if you need to measure the mass of a liquid, you need to put it in a container. And when you finish, you need to subtract the mass of the container to have the mass of the liquid alone. So he measures it empty. The mass of empty bottle is 30 grams. Then filled with water, and the mass of the bottle filled with water is 90 grams. Then filled with ethanol, and the mass of the bottle filled with ethanol is 78 grams. Okay. Calculate the volume of the bottle. Now, why did he use water to calculate the mass of the bottle filled with water? In order to know the volume of the bottle, we need to know the volume of the liquid inside the bottle. The volume of a liquid can be known from the density of the liquid and its mass. Which liquid do we have here that we know these two information? Water. We know the mass of the bottle filled with water, so we can tell the mass of the water, and we know the density of water. So the volume of the bottle equals the volume of water. This is why we need to know the volume, why we are using water in this question. The volume of the bottle is volume equals mass of water divided by density of water. So the mass of water is the difference between the mass of the bottle filled with water and the mass of the empty bottle. So it's 90 grams minus 30 grams divided by the density of water, 1 grams per centimeters cubic. And the answer is 60 centimeters cubic. This is the volume of water in the bottle, and it's the same value as the volume of the bottle. Now, what happens now if I put a different liquid in the same bottle and fill it to the same level? I will have the same volume. So any liquid I put now in the bottle, I know that it will occupy a volume of 60 centimeters cubic. So the use of water here and the use of the information that the density of water is 1 gram per centimeters cubic enabled me to calculate the volume of the container or the bottle. Now we will move on to measuring the density of ethanol. Okay, calculate the mass of ethanol. Again, the mass of ethanol equals the mass of the bottle filled with ethanol minus the mass of the empty bottle. So mass of ethanol equals mass of bottle with ethanol minus mass of empty bottle. The mass of bottle with ethanol is 78 grams minus the mass of empty bottle, 30 grams. The answer is 48 grams. So this is the mass of the ethanol. The third part of the question, calculate the density of ethanol. In order to calculate the density of the ethanol, we need to know the mass, which we've already calculated in the previous part, and the volume. And again, when we calculated the volume of the bottle, here, from the volume of the water, we were able to calculate the volume of any liquid contained in this bottle. So this number here, 60 centimeters cubic, gives me the volume of ethanol. So, to calculate the density of ethanol, the formula is density equals mass over volume. Mass is 48 grams divided by volume, 60 centimeters cubic, and the final answer is 0.80 grams per centimeters cubic. Now let's move to questions of end of unit, questions page 138. I know you don't have the books, but I have the questions scanned for you. These two questions are related to density. The table shows the densities of 6 different substances. So we have a table with labels substance and density in grams per centimeters cubic. Water, copper, paraffin wax, steel, ice, and lead. And we have the density for each substance. Which two substances in the table would float in water? Explain how you can tell. So A. In order to know which substances would float in water, we need to look at the densities of the substances and compare them to the density of water. A substance that flows on water must have a density less than the density of water. So the density of water is 1 grams per centimeters cubic. In order to, for a substance to float in water, it has to be have a density less than 1 grams. So if we look at the densities, we'll notice that paraffin wax has a density less than 1 and ice has a density less than 1. So paraffin wax and steel would float over water wax, and ice, sorry, I said steel, and ice, of course not steel because it's very heavy, it has a very high density, paraffin wax and ice would float in water because they have densities less than the density of water, which is 1 gram per centimeters cubic. Question 2. The diagram shows a cube of marble. Each side of the cube is 2 centimeters in length. Calculate the volume of the cube in centimeters cubic. And B, the cube has a mass of 20.8 grams. Calculate the density of marble. So, in A, we need to calculate the volume of the cube. We are given the length of each side. Of course, you know that the sides of the cube are equal in length, and in order to calculate the volume of cube, we have to multiply the length by height by width. So volume of cube equals the length, which is equal cubed. Here we have a length of 2 centimeters, and the answer is 8 centimeters cubic. B. We need to calculate the density of the marble, knowing that the mass is 20.8 grams. So now we have a volume of 8 centimeters cubic, a mass of 20.8 grams, and we need to know the density. Okay, we use the formula. Density equals mass divided by volume. The mass is 20.8 grams divided by 8 centimeters cubic, and the density is 2.6 grams per centimeters cubic. That's it for today, and that's it for this lesson. I hope that you find everything clear. If you find any difficulties, I'm not going to give you any lessons for next week. You can contact me. Please study the material that we've covered during our stay at home, the online material, and see if you don't understand anything. Make sure to review all the lessons, look at all the videos, and see if you understand everything. I've noticed that the views on the lessons are not as much as needed, and this means that some of you are not even looking at the lessons. So please make sure that you review the lessons, rewatch them many times, take notes if needed, and if you think that you still have some difficulties in any topic, please let me know. Thank you very much, and good luck. I really miss you very much and hope to see you very soon.